Another thing that I think is one of the heroes of software sustainability is picking the right team. So one of the projects we've done, which involves understanding polymorphism in things such as drug discovery, is trying to make sure that you have the right set of people working together. So in this case, what you're looking at is having computational chemists helping experimental chemists understand the different types of structures that can be created by the same sorts of molecules. So a complex molecule can turn itself into different sorts of orientations and other structures. So whilst it has some characteristics which are the same, other characteristics will differ. What's happened in this project, though, is that, again, it's about understanding who you need to have with you. And in this case, the project would only succeed if it had both the computational chemists and the experimental chemists. It had the people who were creating the domain-specific software. So you see there the use of something called DMACRIS, which has been developed by computational chemists, along with the people who had the understanding of the software for the infrastructures that they were trying to run this on. And also, it had the involvement of the IT services and research computing services within the university. So everyone came together, and everyone had ownership of this project to make it work. The other thing that was interesting in this, and is something that's come out of the work we've done in Engage, is that we had someone acting as a facilitator, someone who was able to use, to bridge the gap between all of these different groups and talk to them in the language that they would use when they were discussing the problem, and being able to make that translation. So I think that's one thing that's very important, is understanding how to facilitate a project team where you have people who are working on a lab bench all the way through to changing cards in a supercomputer. Okay. Another one is taking difficult tasks and making them easy. So I mentioned about open source, things that have made successful open source, and you said something about how to achieve mindshare. One excellent example of a project that's managed to do that is the R project for statistical computing. So it started off in the late 80s as really someone's idea of trying to make a better version of S, the language S. But it was publicly released in 1993, and it's gone on from it's taken great strides, both in terms of what it is as a piece of software and in the community it's built up around it. There have been some key things that they've done which has helped this. And I think one of the things that I note about open source software is that the successful projects have made it easy to become a part of the community. So they started off by setting up a mailing list. Well, they started off by open sourcing the software. Then they quickly set up a mailing list. They realized that mailing list was getting swamped. And so they created 3 separate mailing lists to cover announcements, users, and developers. They put things into a public CVS. They created bug trackers. They started mirroring their sites across the world. They split off specific projects like Bioconductor, which took the code base and made it useful for a particular community. They did things such as namespaces. So one of the things that has meant that R has been very successful is that it has the concept of packages, bringing things together which share a common environment and work well together. You also have things such as namespaces, which allow you to trust the different packages and make sure they won't clash. They've done things like internationalization, localization. All of these different things at different stages have been to understand how to grow their community in different steps. And as a result, they've gone from, in 2001, having about 100 contributor packages on CRAN to having, in 2008, 1,400 packages. They've gone from having 2 developers to having over 1,500 developers. So this is an example of a project which has understood what the community wanted and also made it easy for them to contribute.
But it's also an example of getting critical mass.
Yes. And I think it got its critical mass at the same time. The two were mutually dependent. By making it easier, it enabled them to get to the critical mass for that stage of the software. So the final thing, very quickly, is about nominating your successor. And one of the things that people realize on projects is that they are very often all down to one person. We look at Apple. Apple's synonymous with Steve Jobs. Look at Microsoft is synonymous with Bill Gates. Other software projects are the same. Who do we think of when we talk about Linux? For software to be truly sustainable, you need to be able to nominate your successor as well. One of the problems is that as a community grows, it becomes more fragile. Sometimes you do end up with splits. Sometimes you end up with a loss of the cohesion because you no longer have that communal vision that creates a community. What you need to be able to do is understand how to change the leadership, understand how to pass on the torch for a particular piece of software so that this doesn't happen, so that you're always kept fresh and active. Of course, and this is the point I'll finish off on, there are some drawbacks to trying to do that. And it has to be said that we're still learning about the best way of handing things on and understanding how to create succession in software. One video that I will strongly recommend is this thing from Google. And Google have been looking at different sorts of open source projects. And one of the things they found out is that quite often it's very difficult to depose the king. In almost all of the open source projects they looked at, either the person who was the driving force between the early parts of, behind the early part of their project, either ended up sitting around and kind of griping in the later stages, or left in a huff. So understanding how to solve the succession problem, I don't think we yet know about. But if we solve it, then we will be able to truly have sustainable software. So, those were the 5 heroes that I presented in terms of understanding how to make the software more sustainable. Remembering your users, understanding the value in your software, picking the right team, making difficult things easy, and understanding the role of succession. What I hope I've managed to kind of convince you of is not only that software sustainability is important and necessary, but that it's tricky because so many people have slightly different misconceptions of what software sustainability is about. So I hope that you'll manage to go out of this room and take forward some of the ideas that I've been talking about in your own work, in your own research, in your own software, and question the things you hear about software sustainability and find out what it is that's the grain of truth in each of the things that people tell you. So, thank you very much for listening, both in the theatre here and on the webcast. And I know we're now slightly over the 5 o'clock, so I'll finish now.